Good morning again. My name is Zbigniew Czajkiewicz. I am a Dean of the College of Science and Engineering at the University of Houston Clear Lake. And it's my great pleasure to welcome you all this morning to the University of Houston Clear Lake campus and the College of Science and Engineering. This is a very exciting day for us because today we officially launch Center for Robotics Software. For those of you who are not quite familiar with the university, a few data points. University of Houston Clear Lake is one of the 4 universities within the University of Houston system. 3 of those are in Houston, and the 4th university is in Victoria, Texas. University of Houston Clear Lake is organized into 4 colleges. College of Science and Engineering is one of those 4 universities, or 4 colleges. The total enrollment at the university is about 9,000 students, and the college has about 2,400 students, so about 1/4 of the population of the university. As you all know, the main mission of the university is to conduct research and provide a good quality education, and we do that. And we do that in many different areas. In a college, we do it across all the STEM areas: math, science, engineering, statistics, biotechnology, physics, and so forth and so on. But we would like to have a focus area. And one of those focus areas that we identified 5 years ago was cybersecurity. And that was a great success. We have a cybersecurity institute on campus. And today we would like to add one more to it, and that's a Center for Robotics Software. So the question might be, why robotics? Well, if you look around what's going on today with technology and what's happening in the world, everything is going automation and robotics. And robots today don't really look like traditional robots that we remember from science fiction movies. Robots come in all kinds of all kinds of shapes, sizes, different functionality, different applications. There are big robots, there are very small robots. The robots clean your houses today, or at least can vacuum your house, and it's a commercially available product. Robots can perform surgery. Robots can help firemen. Robots can help military. There is a lot of space applications for the robots. So it's a very broad area. Scientists have been talking about very microscopic robots, the ones that they can inject into a bloodstream and they can repair a heart. So it's a very wide area, and technology is fascinating. We would like to be a part of that technology, and that's why we're launching this center today. I would like to thank NASA Johnson Space Center, our partners, our colleagues, for supporting us on that, and we hope we can expand the partnership, and that's why we invited all you today to tell you what we're planning to do, what the center is about, what the technology has to offer, and hopefully we can build a strong coalition of the companies, both private and public, as well as universities, to create a robotics hub within the Houston area. So, again, thank you for coming. We are very excited that you're here, and I hope you will have a wonderful morning. We are planning to go to about 12 o'clock, and then we'll finish with lunch, and after lunch, you will have an opportunity to visit our labs. So it is my pleasure now to introduce Vice President of the University for Academic Affairs and Provost, Dr. Glen.
Good morning. It's my pleasure to welcome you to the University of Houston Clear Lake, and thank you for joining us to celebrate the opening of our newest center, this Center for Robotic Software. This is another illustration of what we say that the University of Houston Clear Lake City is, not city. We are student-centered, partnership-oriented, and very much community-minded. I do want to take this opportunity to recognize the leadership of our new center. So if Dr. Tom Harman and Carol Fairchild are here, they are the director and the co-directors. Would you please stand and be recognized? I would also also like to recognize probably the biggest supporter of getting this new center started, and that's the Dean of the College of Science and Engineering. Some of you may know or may not know, but Dean Czajkiewicz is elected to retire at the end of this summer. So I also want to thank him not only for supporting the new center, but for his service to the University of Houston Clear Lake. I also want to recognize we have a member from our Texas State Senator's office, Mr. Greg Murray. Would you stand and please be recognized? Thank you very much for joining us today. You've already heard that we have a number of speakers from our neighbor, NASA Johnson Space Center. Some of you may not be aware, but I'm a former employee. I was a civil servant at NASA Johnson Space Center from 1976 to 1985. And then I got the bug to get into academia and I came over here. So thank you to our colleagues from NASA Johnson Space Center for joining us today. And thanks again to all of you for joining us. I look forward to hearing more about the new center. One of the things that kind of surprised me is that Baxter wasn't the center director. Baxter's our robot over in the Delta building. Thank you.
Thank you, Dr. Houston. And since we thank you, I'd like to add one more thank you to it. The person that organized this event and who was sending you emails and reminders, Ms. Lori Lopez over there in the corner. So she and my secretary, Debbie McFadden, were here very early in the morning, just make sure that everything will go smooth. So it's my pleasure now to introduce a new director of the Center for Robotic Software, Dr. Tom Harman. Dr. Harman is a senior faculty in College of Science and Engineering. He is a professor of computer engineering, and he is also a chair of engineering department. Dr. Harman.
Welcome, everybody. I see robotics is a popular topic today. I see old friends, former students, colleagues. Part of my PhD research at Rice, we have Dr. Tittle here, was one of my professors. It was funded by NASA. I used to come to NASA a lot to get things calibrated and do work. I was with the Lockheed Control System Department for a number of years. We developed computer systems. We put in Building 49, the reverberant chamber, and did other work. So I'm happy to have the NASA people and other visitors. This is going to be short. I'll tell you a little bit about our mission, the things we're interested in the Center for Robotic Software, and we'll end later today with more details of what our future plans are. Let's hope for the best here. All right, the mission statement is essentially the purpose of this center. The center suggested not just by us at the university, but by people at NASA, by people in local industries, and that we want to communicate and collaborate with other technical groups, government groups, other universities, industries, particularly in this area, to solve problems, to do research. Education, of course, is our main thrust here at the university. So the emphasis is on from our point of view, the robot operating system. I'll explain that just very briefly for some of you who are not that familiar with it. We have some real experts in the robot operating system here, but some may not be that familiar with it. We started using the robot operating system when I got Baxter the robot that I'll show in a moment. A few years ago, Carol joined our team. She pushed me to be a co-author on a book on robotics. And we've had a very good time with it. A lot of people are interested in this, in industry and universities all over the world. It is an operating system that was specifically designed. It was designed at Stanford and a company called Willow Garage. It's roughly 9 or 10 years old, and the idea was to standardize the control of robots. So it's ideal for education, research, and application. So the way the ROS system is put together, it's a number of packages. Packages, for example, that do special things like computer vision, navigation, control, and so forth. And the idea is with any general software that if I'm interested in an application that requires computer vision, I don't have to write the computer vision software, which is would be quite a task. The ROS is open source, so the use is not restricted. And there are hundreds, and I would say thousands, of ROS packages today for various applications. So there are hundreds of robots that use ROS, obviously experimental robots, academic robots for research, and many commercial robots. We have mobile robots, flying robots, quadcopters, drones, etc., submersibles, manufacturing robots that use the ROS operating system as the standard software. There actually are some self-driving automobiles and trucks that use ROS. I think at the moment they're mostly experimental. What will happen in the long run remains to be seen. There are several other development efforts that are going on. There's a ROS industrial that's being developed to use in the manufacturing sector. And there's ROS military being developed for military robotic systems. A ROS 2.0 is coming out. It's redesigned or improved for some of the new technologies. And I think we all know in this area that 10 years is a long time. Things are moving rapidly. All right, we produced this textbook, Carol and I did. It was published in July 2016, and we're updating it for the latest version of ROS. There are improvements. There are thousands of people all over the world that contribute to the robot operating system. And we have mobile robots that use ROS, Baxter that you'll meet later. We have drones, quad rotors that use it. There are ROS connections to many external devices. We can control our robots with joysticks, with keyboards, with programs, with voice, etc. And there's also a robotic system toolbox that mates with MATLAB, and I know a lot of engineers are users of MATLAB. So the area is moving fast. It's exciting. I'm glad to be part of it. Here's just a couple of examples. These are students. We have the master's degree here, or a capstone for graduation with a master's degree. And in this picture, the student is wearing this headset and is controlling the turtlebot down here at the bottom. A mobile robot is controlling it with brain waves. There's no implants here. And amazingly, there are only 5 sensors in this emotive headset. And it's a lot of work. It takes training to the students work hard to control the robot, to move forward, to stop, and so on. Also, we hooked up the emotive system, the brainwave system, to Baxter here. This is a manipulator robot with 2 arms that those of you that are coming to the lab will learn quite a bit more about Baxter and see some demonstrations. This is just one example of projects that we have going on. Our undergraduate students are involved in the NASA Swarmathon that's held every year. It'll be a 3-year competition. at Kennedy in Florida. Last year, I went and with a number of students. And the idea is for these rovers, these mobile robots, will search in a large area, like a parking lot, and they would find recognized tags that were on the ground, and then come back to the center, and each tag that was found and returned, the robot returned, we would get a point. So last year, there were 12 entrants in the physical contest. There's also a simulated contest. And we came out 6th out of 12. Now this year, Dr. Nguyen and Carol went to Florida with the students, and there were 20 entries. And we came out number 4 out of 20. Dr. Becker is here from U of H. His team came in 2nd. He's from U of H main campus. So anyway, this is really an interesting competition. And you might look at these robots, those of you who are not familiar with robotics, and say, well, is that pretty simple? No, there's a lot to it. And the navigation, the searching, getting back to the center was quite a task. It took a lot of work. Those of you who work in robotics know how much tuning is involved in just to get these to behave. All right, so the overall view here is this Center for Robotic Software, of course, is to partner. It's not just for the university, but to partner with our friends. We have the wonderful Johnson Space Center next door, and to partner with them is important. Local industries, other universities. We want to attract students to this program, the robotics track, mainly in computer engineering, but we have people working in software engineering, computer science, and so forth. We want to train and educate some of these students in the latest robotic techniques. And later on this after the other speakers, we'll discuss in more detail what our plans are. All right. So as a summary, we're focusing on the robotic software, the robot operating system, and this has made robot development applications research easier in many ways. Originally, each robot was more or less unique, so software I wrote for one robot really couldn't be transferred to another. The robot operating system has improved that. And as a good segue, we see NASA here at JSC is working on has worked on the Robonaut, and that's in current use on the International Space Station.